Great. Thanks. So, welcome everyone to our second community stand-up. Today with Louis Trümpler from Zurich. The idea of this community stand-up is that we have a look behind the scenes in a way that we publish some open source projects on our website, but that we use these community stand-ups to make the people known behind these projects. Because I think this is one of the biggest strengths of open source projects, that it's often very personal and very driven by individuals. And from my point of view, it makes it even easier to interact with existing projects or with people that work on projects if you get to know them a bit more in person. So I will introduce now, just with like 3-4 slides, opensource.construction for the ones that are new to our little initiative. And then the stage will be free and ready for Louis to introduce himself and his project. So let's get started. So just a little bit of framing where this whole open source construction initiative is coming from. And basically, it's not something that we invented, obviously, open source. Open source institutionalized open collaboration. And I think it's a very nice analogy with the software iceberg, where everyone in the 90s tried to build as much of technology as possible proprietarily and individually. Can actually anyone from you also admit people, or is it only me? Louis, can you see this? Because otherwise I would have always to jump back. And you can?
No.
Oh, you can't. Okay. So sorry for this. I need to adjust the settings next time that everyone can do so. So let me quickly go back here. So anyways, the idea is instead of building a lot of technology just by yourself and having the hassle to kind of maintain everything by yourself, to really differentiate of what makes, like, what is your USP? Like, are you as a person or as a company really strong with, and focus on the tip of the iceberg that looks beyond the water level, and share the efforts that are really related to infrastructure that lies beyond it. And it became and is becoming more and more important, obviously, as you see from other industries. But this mindset is not so common yet in our industry. And that's what we are trying to change a little bit. Based on the observation that almost every organization has some sort of digitalization or sustainability initiative, and everyone's facing the same problems. While you might have really good ideas of how to change things, it's really difficult to create code and create tools that really are robust and scale within your organization, and of course to also maintain them over time. And for us, what is important now and what's a differentiator through the open source movement is that collaboration becomes code-driven. And we really see code as the glue that brings collaboration into practice. Because as soon as we start to use same processes and workflows that are somehow manifested in code, it's much easier to collaboratively improve them and kind of create much more robust solutions that we could do if we just do the same things over and over again in our own organizations. So that the core concept behind this whole thing is obviously don't repeat yourself. And while you try to do not to repeat yourself in code in your own work, I think that actually also applies to a bit of a bigger scale. And with opensource.construction, as we are a non-profit organization driven by volunteers beside our main jobs, our goal really is to create an environment where we bring together developers with users that might be software developers, but often are not in our industry. So we can actually start to understand each other much better. And also, especially from a user perspective, learn of how to interact with developers and find new ways of bringing code-based innovation into practice. Obviously, this can scale a lot. I mean, there's open source foundations in other domains that are really successful in making code-based collaboration accessible, but also trustworthy. We are more or less still at the start, and we focus on what's actually achievable with our scale resources. And what we do mainly is that we have our website where we publish projects on the marketplace, and that these projects can be really small, like just batch scripts that you use all the time and that are super helpful, just like code that you wish you would have at hand instead of building it yourself, to bigger, more established projects like Bonsai BIM, Speckle, that Open Company, and everyone. And we have our newsletter, we have these community calls as we have them today, and we also start to host more and more hackathons, which we think are a great format for bringing people together that can code, but also decision makers who really want to get a better understanding of how this whole sphere of software and coders actually work. And on top, it's something that we are just about to launch soon. It's clusters where multiple organizations come together and intend to work on a project together. And the idea is that through opensource.construction, these projects just become like a little website where you can openly talk about what you do. And it does not mean that every code that's produced in here might be open by definition, but it's really also about highlighting how many code-driven collaborations are out there already. And just to frame it, is that we are not a competition to OSArc, for example, or other initiatives. I think it's more like we join forces and really try to kind of bring this movement and make it more accessible to the outside world. So, yeah, you find us through the website, you find us through LinkedIn. Please get in touch anytime. We're very open for new projects or any input that you might have. But I don't want to talk any longer. It's really about introducing Louis now. He's been spending quite a lot of time actually in tools doing LCA calculations, and then he always hit some boundaries, which at some point made him think of like, why can't I build something like this myself? And when he thought one step further, he figured it actually makes a lot of sense if I do it open source. So I'm really happy to have you here with us, Louis, today. And I'm looking forward to learn a bit more about your journey and your project. So the stage is yours.
Thank you, Max, for the intro, but also for the support over the last year, I would say. Feel free to put any questions into the chat if they come up. I will try to keep me talking to a minimum so we have time for questions and possible discussions afterwards. I usually, and just as a warning, I put a lot of materials into my presentations. So if anything sparks your interest, you can follow up afterwards and feel free to reach out. The presentation will be made available through opensource.construction. And that brings me to the challenges in sustainable construction. The construction industry is very resource intensive, as we probably all know, and in essence, environmentally unsustainable. Together with complex regulations and a general lack of integrations between digital tools and sustainability assessment tools, this really makes truly sustainable practices difficult, from my personal experience. But there is a way, and let's discuss that. But first of all, I would like to quickly cover a topic that often comes up. I often get asked, what is the cost of sustainable construction? And if we look at the cost for a cubic meter of concrete, break it down to a liter, then compare it to drinking water, and it becomes apparent that in Switzerland, concrete is 3 times cheaper than drinking water. And this is similar in most developed countries. So I would say that it is my belief sustainable construction isn't too expensive, but rather The challenge lies in that the way we build is just way too cheap, because we are simply not paying the true costs of our material choices. And it's not only concrete. I don't like to bash on one material. This also is the same or very similar for steel. Just as an example, 1 kilogram of raw steel is cheaper than a can of Coca-Cola in Europe. So it is really a question of how we can allocate the resources and what material choices we make. Who am I? I'm Louis. I'm the one with the orange shoes in this picture, but admittedly, it's been a few years. I started my career as a carpenter, and until today, I gravitate towards timber as a material. I studied timber technician at BFH, and I was lucky to have worked at Val Calmarini, structural engineers for 5 years, where I was able to develop several solutions and use pre-made LCA solutions as Max described it. I've basically built solutions from Excel to Revit integrations there, to instantly assess environmental impact of structure. I very much enjoyed it, and I look back with fond memories. And there's a lot of cool projects that we realized, but it became obvious that my reach was somewhat limited. Sustainable construction is, from my experience, a team effort, and it takes the whole project team with all important stakeholders to actually build optimized. And with that background, I founded LT Plus a year ago, focusing on virtual planning and sustainable construction, where integral life cycle assessment is a key part. Some of you might be wondering, well, what is an LCA by now? Basically, we are evaluating environmental impact, and it can be anything that gets evaluated, from a t-shirt to excavation or construction processes. When we talk about construction LCA, we do a similar thing as putting a price tag on a building, but in terms of environmental impact. And the underlying formula is pretty simple in essence. We need material quantities, we need carbon indicators, and then we can basically calculate the environmental impact of materials. In BIM software, we usually work with cubic meters. So in reality, we need densities to go from cubic to kilogram, or whatever you're using. But then again, most of this data should be available either in form of our IFCs that we produce when we are planning a building, or structure, could be anything. But then again, there's a lot of open data and EPDs that are publicly available, where you can get environmental impact data. This brings us to the most commonly used workflows that I see today. There's the classic manual process, semi-automatic, and then fully automated. What does this mean? I'll break it down and won't go into every detail. Classic manual process starts with a bill of materials, but that gets manually generated, so not exported from Revit or similar, based on floor plans, etc. Then the kilograms get manually calculated, and you can estimate the environmental impact. Usually happens in Excel from experience, and is very decoupled from actual planning, which can be difficult. One step further would be the semi-automatic process, where we basically export a bill of materials from our favorite BIM software. We have to then match materials to go from materials present in models to materials that are present in the material database. And the LCA tool then estimates the environmental impact. This process often relies on proprietary software, and it is crucial to make sure that you know which material matches are generated and what underlying densities are used, because it has a huge impact. If we then go to the fully automated process, which is obviously where IfcLCA wants to be, it's basically identical with the exception that material matching should be done with minimal user input, because this then makes it possible to really quickly generate LCAs. There are a few pros and cons. Less manual input is, of course, an obvious benefit. But then again, it often comes with less freedom in material usage or material naming, because you have to make sure that the material matching is actually happening. And I see this approach totally doable for structural models today, where the material palette is limited. With architectural models, this can be a bit of a different story, especially in early planning stages where not everything gets modeled. If we take a step back and look at common approaches, I would say compatibility and interoperability gets better from left to right. So yeah, we all know Excel can be helpful, but it is often difficult to truly integrate. We have the plugins for Revit and ArchiCAD, where one stakeholder in the project team can assess his model, and then on the right side we have IFC and open source, which I see as crucial if you actually want to build integrated software where all stakeholders can take part. Yeah, building a simple LCA starting point is surprisingly easy. It takes 26 rows of code, could probably even be less if optimized. Uses IFC open shells, gets volumes, and builds a list with element names and materials. Can look like this, and that was basically the starting point for my earliest version of IfcLCA, which was a series of Qt5 graphical user interfaces that you can see down here, and it relied on exporting CSV, importing back into another GUI, and yeah, I optimized that, got rid of some extra steps, some unnecessary export and importing, while still maintaining like the correct calculations, and then finally built my first like monolithic version where everything came together, and used it on some big structural projects in Switzerland. Actually, all versions were used, so that was nice. I was able to be the developer and user at the same time, which gave me very quick iteration cycles. But I also realized three main things. We can't continue with business as usual. The responsibility of the construction industry is undeniable by now. Regulations and the way we work are changing rapidly, and we urgently need new solutions. And I truly believe, as Max said, that open source is the way to promote transparency, collaboration, and building a strong community, all of which are desperately needed when it comes to sustainable construction and the underlying solutions that enable it. But I also realized a few more things. It would be very difficult to finance. I felt that it would be tough to sell my idea because it would be hard to explain what differentiates from existing solutions. We have to be clear. Two very technical topics to come together here. Try to explain that to a banker. Even if you charge 500 per month for an active user, in Switzerland, you would need 20 to 30 users active to hire one developer. And at least at the moment in Switzerland, the market simply isn't there from my perspective, because the value of LCA is still very underrated. No illusions about that. But this could change very quickly when regulations change, as they have started to in some European countries that have adopted mandatory LCAs for building permits. And therefore, change might come quicker than we all think. I also realized it had to be web-based to enable all stakeholders taking part, which was way out of my comfort zone back then. And I thought I could maybe hire somebody externally, which proved financially unfeasible. So I bootstrapped, and I was very fortunate that I have a small but reliable customer base, notably my former employer, Wald Galmarini. So a quick plug, if anyone needs a structural engineer in Zurich, reach out. And if anyone needs a job as a structural engineer, feel free to get in touch. Yeah, what I've built so far is basically a front end and a back end running on a DigitalOcean droplet. Front end has all the views that you can see as a user, the IFC upload, then the material matching, editing table that I'm going to show in a second, and the option to download as Excel. Backend, user authentication, IFC analysis, material mapping after upload, and a managed database also on DigitalOcean. Feel free to scan the QR or click on the link to log in. I hope I don't run into trouble when everybody tries it at the same time as me, but yeah, live dangerously, as they say. I switch to my other monitor. So we can get the demo running. Yeah, you should see the starting screen. That's what you see before you log in. When you log in and you don't have an account, you can register. You get an email with a confirmation link, and you agree to terms and conditions. I do have an account, so I'll log in. And it brings us back to the main page, where you can either start a new project or check out how to get involved, how to contribute, a link to the GitHub repo, even some guidelines, and also a link to a GitHub discussions forum. If we then go back to the main page, we can either start our next project right here, create a name, etc. This project then gets added to the dashboard, where I do have many test projects. You can have as many as you want right now. Always only the latest IFC is saved in the project. When I open a project, I get two graphs, one by building story, which is kind of boring with one story, and another one with a material graph, where you can see actual materials, their impact, and their volumes. In the table down here, you see all your building elements, or even layers of building elements, and the actual environmental impact. Right now, only embodied carbon. You can also add materials. You can add a test material, and you can say you want to add 1 cubic meter of steel, for example, and pump up the emissions of your project significantly. And you can also delete stuff from the table. You just select it and then apply the changes, and those will be deleted. When we start a new project, we have to enter the square meters of the project, and we then get presented with an empty table, and I can upload any IFC to get started. The IFC is then analyzed, all the volumes get extracted, and the material matching is performed based on the name, which then allows me as a user to go into this table, sort it however I want it, for example, by IFC class or by matched material, which then allows me to change the material choices. And you can see the impact that is updating on top. The final step that is possible right now is the Excel export, which allows me to download the Excel file and get a list of actual construction elements used. Yep, quick overview. I'll be happy to answer any questions afterwards. I have a few more slides, and I'll jump back into the presentation to get through that. What I'm doing is standing on the shoulders of giants. I rely on many open source projects or libraries, IFC OpenShell, to name especially, but also others that you can see here. Without that environment, it simply wouldn't be possible to build something like this. So yeah, what's missing? Obviously, by now, no 3D viewer. I have a version with XeoKit that I don't have online yet, but that might be coming soon. And I want to connect it to the graphs, so it gets more interactive. Additional environmental impact data will come, so that not only Swiss echo data can be used, but basically, hopefully, everywhere in the EU. Also, certification in Switzerland, you can get certified as an LCA tool provider to do LCAs for these echo labels, and then academic validation, but also integration into Blender, where I just started on a Python package that would make that possible. As usual, the devil lies in the details. When you want to do certification, you have to include life expectancy, which can be a hassle, especially because the regulations, at least in Switzerland, aren't optimized for the way we work, which means digital. So yeah, there's some challenges there. What I wouldn't recommend, or how some sleepless nights and possibly some gray hair could have been avoided, is I definitely wouldn't recommend building user authentications. I've done that and I regret it. I think I managed to cover all the security concerns, but
Louis, you're on mute now. I can't hear you anymore.
Thank you. No. Setting up a server, at least as a non-Linux user, is something I definitely can't recommend because of the steep learning curve. And I think there's managed solutions that would have been better for a beginner. And then again, trying to scale a monolithic application is something that, at least for me as a beginner, wasn't simple. And I even today struggle with, or I think about splitting it up into different microservices. So yeah, your turn. Please check it out and feel free to give any feedback. More than happy to receive that. And yeah, thanks a lot for your attention, and feel free to ask any questions now. Just as a heads up, I have put in additional resources, so if that is interesting for you, please check out the presentation afterwards.
Great. Thanks a lot for this very nice presentation. Let's start with the questions that are already in the chat before we jump into a more open discussion. One question was whether this is only applicable, or like whether this would also be applicable to infrastructure projects, which I guess it is, right? No limitations here.
Yeah. The only thing you need is an IFC. It helps if it has sensible material namings. And of course, in infrastructure, you don't have building levels, so the top graph will be useless. But yeah, feel free to reach out if you need anything.
Have you documented somewhere the prerequisites for IFC models?
I actually haven't, because there used to be none.
Okay.
I've changed that, so I should document it. You need base quantities now.
Mm-hmm. Okay, but you don't really need a lot. It's really straightforward. You use base quantities. There's some material names assigned, right? Or okay. I think let's go step by step because we will talk about materials in a second. There was one question from Michael. He was asking whether why you choose Python and not JavaScript if everything is web-based.
The front end is fully JavaScript. The only Python thing is the actual IFC ingestion, and there I just chose IFC OpenShell, which is Python, and yeah.
All right. And the other question was from Andre. He says, or probably like for the material names to be matched, they first should go through a quality control. You know, like probably it's targeting if you automate it and then you get some results, but like how do you actually make sure that you match the right materials with the right values from KBOB or from the environmental data list that you use?
I didn't mention it in the presentation, but I am working on material presets, material config presets, which allows you as a user to basically build up the pairing yourself. So what you can then do is my material in the IFC, which is called concrete, will always map to this and that. So you can kind of build your custom mapping. And regarding quality control, yes, definitely. And it's not only names or material names, but volumes in general and base quantities should be checked. But I guess this applies independent of the context.
True. And I think it's also important that like you do it as a project and it should not need to cover everything. I mean, enable quality and have automated processes. So it's very valid to also focus on what's the real differentiation. Probably one question from my side before we open it to the others. Like for now, you have KBOB, which is the material data list in Switzerland, available to the users. Have you implemented other databases like the IfcLCA or something?
Not yet, but it's definitely on the list. I'm also in contact with Fanos from 2050 Materials. So yeah, there's definitely a lot of potential there. What then becomes a bit difficult is it's actually changing the database is really simple, but actually in different countries there's different regulations for LCA. So it's not only the data that is different, but it's actually the way we calculate. This is not relevant or not very relevant with how IfcLCA works today, but it might become more relevant when we are talking about certification and stuff.
So it might be good to find people from Germany, for example, or Denmark or other countries that actually build similar tools to kind of join forces, and that would probably be a good push to build the entire thing a bit more less monolithic, more based on microservices that talk with each other.
And I've seen there is a lot of interest in that direction. So yeah, again, feel free to reach out.
Cool. There's one more question from the audience. It says, what do you think of using ontologies in IfcOL for applications like LCA, like IfcLCA?
I don't know IfcOL, to be honest.
Probably also, and if you could frame your question, you can also unmute your mic and ask the question directly. Probably it's easier to give a bit more context.
Hi, thank you. Actually, IfcOL is a version of IFC in a way that it is more interoperable. So it's kind of a different language, and it doesn't use Express. But if you don't know the IfcLCA, you can just maybe mention your opinions for implementation of LCA for more interoperable systems in the future.
Yeah, definitely. And thanks a lot for IfcLCA. I'll dive into that. Very interesting. I do see a lot of potential for actually integrated solutions. The actual challenge here is that it's pretty easy for one stakeholder in the whole construction planning process to build his internal processes. I've seen beautiful Power BI dashboards for structural engineers, which is great. And I've built those myself. But in the end, what I've seen in real projects is that it takes every stakeholder. It takes especially the owner, which has to pay in the end. And from my experience, none of the actual existing solutions today truly enable that. So I hope that kind of answers your question. Otherwise, feel free.
Jumping in here, what I'd be interested in is like, because you said you have lots of feedback from the community. Like, could you give us an idea of like how many of these people that interact with you do have some sort of software engineering background, or like do know how to code, and how many are just users of the tool, like front-end users?
I don't really know, actually.
Okay.
I think the boundaries aren't as clear in our industry, because at least that's how I started, with a little bit of Dynamo on the side. And I'm not sure. Can you call yourself developer?
Yeah. At least you look into code and stuff, because I think that's the interesting trend, also seeing your project. I mean, you've been a user for many years. You've been frustrated what's possible, then you figured it's easy, I can do some coding, and then you started with a project, and then you kind of consolidate your know-how, which is cool, because you just increase your toolbox by a lot. And through the open source movement, I think like discussions that you had with Diane Mold, for example, and others, are really valuable. I mean, you learn so much by just doing it and by opening up, and instead of just watching YouTube videos and trying to learn everything by yourself, you go out in the open, accepting that not everything that you do might be state of the art and there might be better ways, but that's a very beautiful way to learn it, actually. And increase enough momentum that more people that have a more understanding probably propose better solutions, and only then it really becomes really robust and everything. So I think it's really cool to see this. Like, are there any other questions from you guys, from the audience? Like, is anyone thinking about like implementing some LCA process into existing workflows and considering to use? Yeah. Hi.
Hey, hello. Yes. So I am sort of also working on making a system for this, but then for the interior building industry. And I have a question about, because now you just sort of see what's done, right? So this is what we build it. But are you also trying to include a system that you can, during the design phase, and also say, hey, maybe you shouldn't use concrete, maybe you should use CLT, for example, that you push them to make better and more sustainable choices?
Yes. I think there's a few challenges, but also big opportunities there. And I am very careful with substituting concrete with timber, because you have to do some more stuff to the building than just switch out the materials to actually make it work. That would be impossible to actually simulate. But like inside of a material, staying between different concrete grades or concrete mixes, you don't change the material properties a lot, but you can have dramatic impact on environmental impact. And I think that sounds a lot more feasible. Giving feedback like, hey, if you would switch to another concrete mix, you could save 30% of emissions. That would be great. And I believe that's doable today. I think it's very interesting to see or to hear that you're building something for interior, because that's totally not what I cover. Stuff like painting on the wall, even furniture, and is very important. Should never be underestimated. But with my approach that I take, I believe it would take a lot to actually make it work. So yeah.
It's that the reason why I ask it is that, you know, having the data out there and seeing how many CO2 your project costs is one thing, right? But I think the impact can be more in learning how to interpret this data, and then, you know, make better choices from the start. So well, thank you very much, and also to share this open source, because I know how hard it is to earn money with open source. Thank you.
Thank you. No, I really agree. And I think the whole what if question is very important. And as I said, there's a lot of potential there to ask yourself, what can we improve? How can we compare different versions, and how can we do it quick and reliable, so it becomes scalable.
Roman had another question, I think.
Hey, just comment on what Marie brought. Our studio did a project that was only interior, a refurbishment for the International Museum of the Red Cross in Geneva, that we tried to do with reused objects only, and we did a lot of calculations there to see what was the impact, and the result was quite sad. Like, we compared to actual construction, the amounts are super, and especially compared to the efforts that was put into the project, the numbers are really small, but the big value in this project lies in the story that it can tell, that it's a public space, it's a museum. They have attached information to the process and to the emissions that were saved, to all the chairs and to stuff in the foyer. So just as a reminder that the value of this work is not always in the numbers, I think. It's also in the communication.
Thanks a lot for that. I totally agree. Is it kind of sad that we don't have the same relationship to our structure that we do have to our furniture? I kind of feel this way. It would explain something. Because reuse in structure can be sold too, but at least from what I see today, it's really a niche still, unfortunately.
So I want to go back to another topic, like we've only touched briefly, the open source aspect of things. And I think you framed it nicely when you said, like, you could have built this as a proprietary tool, but like, how far do you really get, and will you get a market share? And I had a startup beforehand where we actually also built some sort of an LCA analysis tool. And one big issue there, obviously, is interfaces, like on one hand side to existing software tools, on the other hand of side to just available material data. And this is why I think that for a process that is as crucial as the LCA, there should be some like open source engines that everyone can use and collaboratively improve. Because once you got more and more users using with that software, interfaces will just be more standardized, because it makes much more sense to build interfaces, probably even community driven, to such a tool than to a proprietary solution from yet another startup or one of the big, tools that are out there already that don't really listen to the individual needs that you might have as a user. So that's quite a sweet spot actually for something which has a high need, but also a high degree of adaptation. Like, you need to adapt it to your individual workflows within your office, while you don't want to reinvent the wheel of where to get the data from, how to do calculations and everything. So I really hope that you or we together can really trigger a bit of a better movement into this direction, where we say everyone needs to calculate LCA. It has to happen in every project across multiple phases. And it is as integral that we don't want to rely on startups that we need to pay license fees for it, because these startups will not survive on it for long anyways. So it'd be interesting to hear probably also from the audience whether this makes sense to you and whether you see some points of interaction from your own daily business. Andre?
Yes, thank you. So for us, like, I was thinking, like, I really like what you said and really see, like, I was thinking, how can we do it? For me, in my company as a general constructor, we get the IFCs from all the planners. So we already have the main information. We do the quality assurance. So then we should go, we can use a tool like this for sure, but I don't, like, the owner is not asking for this. No?
Mhm.
So it's like, it's our initiative to start doing it, but then for what? What's the goal on it? Like, will we put in trouble our relation with the owner, saying him like, hey, you ordered this and now we should do it like that? Like I see there like a little bit a conflict. Like, how would you recommend to get this topic with an owner?
I can really relate to this issue, because I've seen this firsthand at the structural engineers I worked at. It basically started like there. I would say Val Calmarini today is at the forefront of sustainable construction in Switzerland. They are involved in some major tall timber projects and other like lighthouse sustainability stuff. And this has changed dramatically over the last years.
Mhm.
And it started with us developing solutions and being able to present those, at architectural competitions that were won. So I really think it can be a differentiator. But I think it shouldn't be the main motivation. I think it should be intrinsically. I think management of any big corporation today should be able to accept their responsibility, their environmental responsibility, and therefore I think it should be pushed.
Mhm.
And I am very sure that it can be a unique selling point.
Well, thank you so much.
So thank you. There's one last question before we finish our call, Enrico. Just
Yeah,
jump
hello.
in right
Yeah.
in time.
Yeah, hello everybody. That's the question. Yeah, let's say I'm the owner. That you come to me and you say, hey, look, I've got this tool, and I'm the owner. I'm now for the sustainability, a fan of the sustainability, and I just say, yeah, you just cost me more, or it's going to cost me less. That's I think that's the point. So either I believe in sustainability, or I don't believe it, and I don't do it. And probably the only way is just I'm saving money, yes or no. Thank you.
Yeah.
So it comes down to the end.
I've actually seen both ways. I've seen a lot of money spent on projects for sustainability, and I've also seen money saved with only doing what is necessary because of sustainability effort. What we also should never forget is that it's not only about carbon. I only talked about carbon today, but actually sustainability is very multifaceted, and it can mean it does mean different things depending on who you talk to. So I've seen clients realize very expensive buildings, all timber, using huge amounts of raw timber without glue, which caused a lot of CO2 emissions. And that could have been built with less CO2 using like manufactured timber. But for that client, it was the right choice because it made sense for them. They knew where the wood comes from, etc. Then again, especially with concrete and structure, the actual emissions often lie in rebar. So saving rebar is actually cost effective and also effective on CO2 emissions. If you can leave something away that is unnecessary, you usually save money and you usually save emissions.
That's a very good framing, and I think creating a better understanding for all stakeholders across the entire industry is to make it more accessible through tools like IfcLCA that should be available to everyone, are robust because many people use them. And so if it's like you do cost calculation and statistical calculations, if it's just no additional effort to actually calculate the LCA footprint, everyone becomes more proficient in these discussions. And I think that's also very relevant for the industry. So thank you very much, Louis, for your efforts. Greatly appreciated by us and hopefully many more in the future. So don't hesitate to reach out to Louis or me, and we will keep pushing. Thanks, everyone.
Yeah.
Looking forward to see you soon at the next occasion.
Thank you. Bye-bye.
Bye.
Bye-bye, guys.